Hello YouTube, iFixItAll here, Team iFixItAll. So here's, I guess, part 4, because I accidentally hit stop or something. So what I've done here is clearanced. I have okay, so I have wired these outlets up differently than the previous one you saw. I've got my hot leg traveling through, and it is dead end up in there. The ground is passing through. My neutral is passing through, but I've got the neutral leg clearanced from the hot leg, clearanced from the ground leg. So let me go get an inverter and let's do some terminations. Same ordeal as before. I left little pigtails because I can put my copper conductors through there and then crimp that pigtail shut, so that if this thing ever overheats, the wiring will still stay put because I've got some crimping action going on along with solder. Okay. Sounded pretty aggressive there. Here with that. My God. There we go. Not a single hair damaged. Tin coated copper. At least I think it's copper. Really hard to tell. Let's get our hot leg. How does this mount? This goes like that. So that means my hot goes here. Decisions. I think I'll pinch this off just like it is. and curl this over like so. Then add a shit ton of flux and solder. We'll see how much solder we can get to take. How do I come at this with that great big soldering iron? I may step up the size solder I use to this stuff here. Probably gonna heat up some insulation, which I want to try to prevent. And I've got to be able to breathe too. That's important. I wish I was... I'll try it left-handed, guys. That ain't setting still. I need a weight. I need a weight on that. This ought to be heavy enough. Left-handed. Take one. Wait for the solder to, the flux to start boiling. Take away the heat. Breathe. Let's take a look at what we've done. Plenty good. Very happy. All right. Pinch that together with my nail nose. I'm basically just rolling that pigtail back around and squishing a little bit. Zoom you in so you can see. Let's try to do this solder connection with you zoomed in. Yeah. I'll try to roll this over now. This away. Okay. And add a crap ton of flux. Should wire brush this off again. If your tip gets dirty, it doesn't transfer heat too well. Okay, so I've got flux. You guys are in frame. Let's add some heat. Oh, add weight too. Hold your breath. Wait till the solder starts to boil. And then wait a little bit more and then start bringing solder in. Huh. All right. Let the smoke clear. That looks good. Kind of like the way the wires are flowing. We got to bring the ground all the way over here. And try to reshape this ground if I can to do an S turn. Hopefully my pigtail's not too small. Open it up a little bit, just in case that is the case. There we go. I'll crimp that off some. There we go. Bend that around. Add flux. Add weight. See if you're in frame. It's drifting. Alright. Now, add heat, hold your breath, and wait for this flux to boil, and then add solder. Get some alcohol prepped. Toothbrush. There we go. All right. Let that dry off. I'm going to go put my chickens up and I'll be right back. Chickens all went in the coop by themselves. It's so cool. There are a couple of violators that hang out and try to nest in the tree or something. So what do you guys think? I think it's much happier with this approach. So I'll just repeat everything that I just said because my microphone was too far away. Chickens put themselves to bed. We had one violator. She tried to, well, violators meaning those who refuse to go in the coop. What do you guys think of this? Much lower profile than the original, which sits right here. Takes up less real estate as far as space engineering is concerned. And plus, those slots just don't accept plugs easily. You can literally unplug something and destroy the faceplate because you'll crack it or break it. I just don't even think I'm going to save these. Usually I harvest parts and put them in a bin. Everything's got a spot. Everything's got a spot for what it's for. Drying out seeds. Everything has a spot. But I don't even want to save this back for someone else. It's garbage. I'll save the heat insulators. I'll save that back. But the rest of that's just garbage. Yeah, I like that a lot better. Let's button this thing up. Let's see what we can do. Got some cool air coming in through that window over there. Gotta fix that. Alright, so we don't need the alcohol. First things first, slip that under. Feed that panel through. There we go. Form the wires. Create the arcs that they need. Looks like everything's clearancing okay. There we go. Now all I gotta do is just massage this in place and get those wires to... I need to determine if this low wire here is going to be a problem. Bend it a little bit. I think that'll be pretty good. Oh yeah. Yeah, there's not a damn thing wrong with that. Not at all. Put some side rails on it. They sure the hell have this thing engineered. I mean, geez, let's... There we go. That. Scoot that over. I mean, you can't even put these on upside down. Okay. Double checking my clearances here. There's the final look-see. The only thing I see is this right here. There, that's off the circuit board. I think I'll get a couple of screws in, prevent what happened to me last time. A couple of these right here, right here. Well, what I do know is I don't screw into the side walls, I screw into the cover. So therefore I need a cover on right now. I think I'll put the back screws on first. Oh no! Forgot to put the screws in for the front panel board. Alright, I'm not going to make you suffer through that error. Gotta put these screws in. Dang it. Just got done massaging everything in place. Alright, be right back. I gotta put these screws in right through here. I'll let you watch me do one at least. Find the proper screwdriver. And I believe that's the screw hole right there. We get 3 more in. I'll be right back. Okay, corrected my issue. God, this thing is like, it's not a pain in the butt. I understand what I have to do, but there's so many moving parts when you crack this nut open. There we go. Maybe I should put the bottom screws on first and the feet. At least get something started in that arena. By the way, on the last video, or the video before last, the last one where we tested one, I'd not no sooner than turned the video off that we lost power. So I had to immediately go deploy that completed inverter. And honestly, I wasn't in a big rush to get all 3 of these upgraded. But it's a good thing I had that one. And like 6-hour outage. That hit. That's good. Oh no! My magnet flipped over. It's taking screws from somebody it shouldn't be. There we go. Get that hardware over there. I'll recap on the internals of this. All the parts on inside, capacitor wise, the capacitors are not the very best, you know. They're probably mid-scale. Everything was the same name brand. Also, all the MOSFETs were the same brand. all of the parts inside here, at least they're all consistent, which is very important. Okay, that might have been the key to everything. With the trouble I was having before. Okay. Dang it. Daggum magnet flipped again. I've got them too close to each other. I'm not liking how it's gapping over here. Something's not jiving. Let me put the back ones in first. God, this thing is engineered. Mm-hmm. Alright, why do I have a gap here? Okay, that's better. There go my screwdriver. Oh my God, this thing is over-engineered. I hope the fuck this guy went to work for NASA. Problem is, you can assemble this wrong. I mean, and it'll go together. It just won't be right. Because whoever engineered this, they were looking at every little tiny damn detail. Like everything. The fitment on this is very good. I mean, there are no sharp edges. If you get done putting this together and you have any sharp edges, you are wrong. Wow. Okay. Whew. I think I owe the bottom side here 2 screws. I'm not screwing into a hole, I'm screwing into a channel. And the odds are pretty high that you're cutting new threads when you're doing this sort of thing. It's a channel you're screwing into, 2 walls, just wide enough to slip this screw through. Alright, let's bench test this thing and see if it fires up. Hang tight. So I got my car idling out there, and I got my 12-volt source here. See if we get that flash of blue lights. Yep. And we're gonna prop it up again, power it on. I don't think we need that big bright light anymore, do we? It should be fine. So we got it powered on the back, now we got to turn it on the front. And it defaults to telling me that I have now look at this one, it's showing 0 watts. Oops, I powered it off. I'm not sure I'm liking that voltage coming out of the alternator. That says 14.9 and 15. I think my alternator is giving me a sign that I'm on the way out. Can you guys see that? To me, it shouldn't be 15 volts because I'm going through about 30 foot of 6-gauge power cable. I'm going to go out there and check my battery just to double check. It might be that meter is a little flaky. Hang tight. Okay, I'm back. I think it has a little bit more to do with that being wrong. My battery's saying 14.7. Let's see what our output voltage is here. AC volts. It's saying 117. I'll give you a couple of angles of the dangle there to where, just in case you can't read it. and it's showing 0 watts load. Let's check the other outlet. 117. Just for schnitz and grins, I'm going to go from neutral to ground. Yeah, I got 30 some volts neutral to ground. So you never ever want to tie any of these inverters to anything of a ground or neutral in your house. Just keep these damn things wired off your house. Okay, go hot leg to ground. It says about 30. Yeah, I don't know how this inverter's making its 117 volts, but for whatever it's worth, does it run a jigsaw? Let's put some watts on it. Neutral tang. Right there. Let's see what kind of watts we got. Now the other inverter said I had 350 watts. Or 340 some watts. Alright, so this is 3.2 amps. Let's just use 120 volts. 3.2 times 120 should be 384 watts at full max. It's not really loaded though, it's just free spooling. But the other meter saw the meter base on the other inverter said 350 some watts. I don't even hear the fan running on this one. Maybe it's just not hot enough. That plug works. Test this plug. Okay, there we go. I think this is part 4. I think we can end this series of inverters because I've got one more inverter left. We can end this project, guys. Got one inverter left that needs its faceplate modified, and I will do it just like that one that we just tested. Alright guys, you have a great day. See ya. Bye.